my master's student, Liam, he basically featureized time series. So like a time series, this is univariate time series, that's where there's been quite a lot of research on foundation models. So univariate time series is basically for each timestamp, you have a value. And then you just have this one signal that changes over time. And you can cast this as, well, each timestamp, you can say, well, this is a time of day. This is a day of the month. This is a day of the week. This is a month of the year, etc. So you can basically create these features from it. And then you can also, for any time in the future, for example, like 5 hours in the future, or 5 days, or 17 days, or whatever, you can compute, well, what time of day is this going to be, what day of the week is this going to be, which day of the month, etc. Then you have these features, and you just put these features, so that the training data is going to be your time series so far and its featureization, and the test is going to be the point in the future where you want to predict the featureization of that. And then the question mark to predict is, well, the signal at that point. And he just put it into TabPFN in this very simple representation, and it directly actually worked better than the best time series foundation models. So foundation models specifically trained in order to do well on time series, foundation models trained on many real world time series, etc. With lots of data augmentation tricks, also other extensions or follow-up works of our first PFN papers and TabPFN paper. There had been extensions to forecasting. People had already simulated time series data and had some priors for time series data. But this new model doesn't have any of that. It has never seen a real data set, and it has never seen a time series, and it has never seen the particular featureization we used for a time series in order to make it a tabular data set. And nevertheless, it just works out of the box. It still blows my mind.